Okay, in this video I'm going to do a couple more complicated concentration questions where I'm going to go from, say, one concentration definition to another concentration. So it's a little bit trickier here. Vodka is going to be our example here. It's listed at 40% by volume ethanol, and we're going to try and change that to a mass-to-mass concentration. Note we have the density of ethanol here to be 0.789 grams per milliliter, and it's not noted, but the density of water is 1 gram per milliliter. That's our definition of a milliliter. So with that in hand, 40% by volume, the trick with these questions is to realize that you can assume an amount of the substance. The concentration is going to remain the same whether I have 10 milliliters of it or if I have 100 milliliters of it. So I can use any amount that I want, and then with that I can start converting things over, and it doesn't matter how much of the original substance I use. So let's see what I mean here. I'm going to assume a total volume of 100 milliliters. Again, if that's the concentration for 100 milliliters, it's the concentration for 10 or 1,000. So this is just an arbitrary choice that I'm making. If that's the case, and it's 40% volume by volume, then my concentration, volume to volume, is 40%, or 0.4, and that's the volume of my solute divided by my volume total. So if I assume 100 milliliters total volume, what that means is I have 40 milliliters of my solute. If I have 100 milliliters total, and I have solute at 40 milliliters, then I must have, assuming that this is a solution in water, (60 milliliters of water. So now I have my volume of my solute, which is my alcohol, the volume of my water. I can use the density of each to get the mass of each item. So density equals mass over volume. So for the water, 1 is equal to the mass, 1 gram per milliliter, mass 60 milliliters. And so my mass of water is 60 grams. And for my solute, which is alcohol, my density is 0.789 grams per milliliter. I don't know my mass, but I have 40 milliliters. So I can multiply both sides by 40, and they get my mass of my alcohol. So that's the mass of my water. This will be the mass of my alcohol, which is 40 times 0.789, which is 31.56 grams. And now if I want my mass-to-mass concentration, I need the mass of my solute divided by the total mass. I don't have my total mass, so let's just figure that out. MT equals the mass of my water plus the mass of my alcohol, which is 60 plus 31.56, which is 91.56. So I've got 31.56 divided by 91.56. Those are both in grams. Grams, 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 grams. Put all my units all over the place. And I get 0.345, or 34.5% by mass. So it was 40% by volume, meaning 40 milliliters out of the total 100 milliliters was vodka. And in this case, it's in mass to mass, it's 31.56, but the total mass of the solution is only 91.56, so it's actually only 34.5% mass to mass. So that's one tricky one. Let's look at another one, and we'll see it sort of has the same basic trick at the start. Vinegars 5% acetic acid by volume, determine the molarity. So again, with this, concentration doesn't depend on the amount of solution I have. So the first step here again is going to be to assume a certain amount. I'm going to assume 100 milliliters of solution. Vinegar, the concentration, volume to volume, is 5%. Or remember, whenever we put percents in equations, we always have to convert them over to their decimal form. That's the volume of my solute to the volume total. Now again here, I've used an assumption that I'm going to have 100 milliliters of total solution, so that means I have 0.05 to 100 milliliters, and that's going to be the volume of my acetic acid. So that's just 5 milliliters. If I want molarity, that means I want moles, and moles are based on mass, so I've got to take this volume and convert it over to a mass using the density. Grams per milliliter. So that's going to be 5.25 grams. And then if I want that in moles, I need to find my mass divided by my molar mass. Now my molar mass here is C2H3, so I got 2 carbons, 2 grams per mole, 2 times 12 grams per mole for those carbons, 1, 2, 3, 4 hydrogens, and then 2 oxygens. So that's the molar mass. Again, if you don't know how to do a molar mass, you should go back to other videos. So I got 60 grams per mole. So I have 0.0875 moles. Now that's how many moles of acetic acid I have. I got to go back here and get my molarity, or my concentration in moles per volume. And here I'm going to go back and remember my original assumption that let me do all this, which is that I have 100 milliliters of solution. So my moles is 0.0875 as just calculated, but my my volume is 0.1 liters. 100 milliliters is 0.1 liters. So that's my, I assumed 100 milliliters, so that's my assumption there. So I have 0.875 molarity, or remember that capital M as a unit stands for moles per liter. So that's how I get the molarity of something that is originally given to you as a volume concentration.